I'm in the process of measuring the voltages on the CRT drive card, or the sweep board like they call it, and I'm concentrating my attention on the vertical output, which is the part you're looking at right now. Now you see these two parts I already replaced. This diode, which originally was a germanium diode, an IT22. Now, unfortunately, I just can't lay my hands on a germanium diode any longer, at least not of that type. Oh, there are other types still available, and the reason why they used a germanium diode for this one is, I think, because germanium diodes back in the days, I mean in the 60s, had much faster switching characteristics, which means that they could handle rapidly changing voltages, and we're talking about kilohertz range frequencies there. Now, I had a look at the characteristics of a 1N4007, and it appears that the 1N4007 has quite similar characteristics to the IT22 germanium diode. Of course, the 1N4007 is a silicon diode, but still, in the kilohertz range, the 1N4007 seems to perform just as well as the IT22, which is here, and even better, because the peak reverse voltage of an IT22 is a maximum of 100 volts, whereas the peak reverse voltage of a 1N4007 is 1000 volts. Also, the IT22 can only handle about, say, 60 to 80 milliamps, whereas the 1N4007 can handle almost 1 amp, and at a much higher working temperature. Anyway, I replaced these parts because I had serious concerns that they would simply fail. The resistor you see here, which was supposed to be 18K, was 25.5, and the diode here let through current in both ways. Yeah, and how did I assert that? Well, by measuring its resistance in one direction and then in the other, and they were similar. Yeah, in the normal conduction direction it was about 22K. In the non-conducting direction it was about 31 or 32K. So yes, well, I think the diode was bad. I'll check on it again once I get the TV working. Now, I shifted my attention to the vertical output power transistor, which is this one here. And you'll notice that they also mark voltages at the collector, the emitter, and the base. Base is supposed to be 1 volt, collector is supposed to be 9.44 volts, and emitter slightly above 0 volts level, so I would say 0.4 volts. So I proceeded to measure the voltages, and I did notice that the voltages in general were off. The collector voltage was off by almost 2 volts. The base voltage was off by about 0.6 volts, and the emitter voltage was off by 0.2 volts. I think that the voltages were all a bit too high because I replaced a lot of parts, and the circuitry was needed to be aligned a little bit better. So I went to look for this vertical output bias potentiometer, which you see here. Yeah, and this in effect changes the voltage with which the base of this power transistor is driven. Okay, right. So I went to my service manual and I noticed that there is indeed a potentiometer which is marked vertical output bias. Now you'll notice that on the schematic somebody wrote that you should switch those two top potentiometers in position, let's say. So actually the vertical output bias potentiometer is not the lower of the two, but actually is the top one. And what do you know? If you look at the print board and you see the top one here with the red lacquer here, then according to the schematic, this is the vertical output bias potentiometer. I adjusted it, and indeed I did manage to bring back down the voltages to their correct level on the power transistor, the vertical output drive transistor, which is that little TO5 or is it a TO3? Could be a TO3 housing transistor. You see, the one where the red crocodile clamp is attached to. So I started by measuring the collector voltage, which, as you'll remember on the schematic, is marked as 9.4 volts. Okay, so that is what the red crocodile clamp should be measuring. So let me show you on the multimeter what it is now. Okay, it's still rising a bit. Okay, almost 9.3 volts. Okay, 9.36, 9.38. Okay, close enough. Good enough for me. It should be 9.4. Let me see. It should be 9.4 volts. It's actually 9.36 volts, which is, well, almost there. Yeah, I could try to make it 9.4, but this is more than good enough to me. So the collector voltage is okay. Unfortunately, if you look at the screen, we still only get a horizontal line. But look what happens if I move the print board a little bit. Okay, patience, patience. Well, that's typical, of course. Now nothing happens. But anyway, what did happen a few minutes ago when I moved the print board is that suddenly I got, for just a moment, vertical deflection. And that seems to suggest to me that the problem is actually not the transistor nor the parts, but they're a bad contact. And in fact, you see, the voltage jumped up at the collector to 14.3 volts. And there you see, when I move the print board, the voltage drops back. Okay? So in effect, there is a bad contact on this print board. And there you see, when I move the print board up or down a bit, at certain moments I do get vertical deflection. Bad, of course, but I do get it. So my guess is that the connector board, or the connector I should say, which connects the CRT drive board to the rest of the TV chassis, is dirty. Or perhaps one of the cables is loose. Or perhaps there is simply one of the solder joints that is broken. So what I'll do now is I'll shut down the TV and I'll pull out the print board once again, and I'll have a look at the contact, the print board contact, and all the cables which connect it. And then I'll have a look at all the solder points on the print board, and I'll retouch them if I think they are bad. And then we'll give it another go. I thought, well, okay, if the voltages are okay around the vertical output transistor, then I might as well go down the line, and go to the vertical drive transistor, which is, in fact, you could say, a kind of a amplification transistor. Okay, it sort of provides enough current to drive the power transistor. Yeah. So I started measuring the voltages around this transistor, and they were deviating a little bit from what you see here. So the voltages were closer to 13.1, 13 volts around the base and the emitter, and the collector voltage was more like 8.7 or 8.8. I also measured the resistors, these two, and obviously I replaced this capacitor, so I thought, well, okay, the two resistors are okay, the capacitor is brand new and it is correctly connected, so let's go further down the line. So we arrive at the vertical oscillator transistor. Now the vertical oscillator transistor is that which produces the pulses, as it were, to drive the vertical deflection of the electron beam in the CRT. Yeah, so this is really what makes the scan lines, the horizontal scan lines, move from the top of the screen down to the bottom of the screen. Yeah, and that's how you build up a picture. So anyway, I started to measure the voltages around the transistor, and funnily enough, I measured, instead of 5.5 volts at the collector, something like 12.4 volts, which is obviously way too high. whereas the voltages on the base and on the emitter were very, very low. I'm talking about in the range of tens of millivolts. Now, I know some people would have the reflex of saying, well, it's very probable that the transistor is broken or damaged. And I thought to myself, well, okay, but I'm going to hold off a bit on trying to measure the transistor, because if you have to unmount a transistor from a PCB, it's a lot of work, and you risk damaging the transistor as well as the traces to which it is soldered. So instead of unmounting the transistor, I started measuring the parts. I measured this resistor, which is, according to the schematic, an 82 kilo ohms. And in reality, I found it was more like 83 kilo ohms, but that's fine. I mean, that's a margin of a negligible margin or error, let's say, from the rated value. I went to the next resistor, which is supposed to be 1500 ohms. Now, interestingly enough, this resistor here, which is 1.5 kilo ohms or 1500 ohms, measures 690 ohms. Now, again, the reflex would be, oh dear, this resistor is maybe bad and should be replaced. But I thought to myself, well, you know, okay, the value is quite off, so by 50% or even a bit more, but it's 50% lower than the value it should be. And then my eye fell on this capacitor here. So I said to myself, well, okay, I'm still measuring the resistor, so let's go ahead and measure this resistor first. As you can see on the schematic, it is supposed to be a 5600 ohms resistor, this one here, or 5.6 kilo ohms, and indeed it's very close. It's something like 5560 ohms or something like that, which is really perfect. I also measured the resistance of this coil here. Now, on the schematic is marked that it should be 9 ohms. And when I measured something like 9.3 ohms, which is really nice. There was a small detail, you see here, red dot. Yeah, and I think that red dot is just to indicate where this coil is located on the PCB. And if you look at the PCB, you do indeed see a tiny little red dot over there. Okay, so I had a closer look at the oscillator, because you see there is no vertical deflection at all. Okay, so that would tend to indicate that the oscillator is not oscillating. Now, in general, although not always, oscillators are built around an RC network, yeah, which means that you need a capacitor and a resistance to create a sort of a charging of a capacitor and then a discharge. and that repeatedly charging and discharging is what generates a certain frequency. Yeah? And so, like I said a minute ago, my eye fell on this capacitor. Now, as you can tell, it is supposed to be an electrolytic, and in fact it is an electrolytic. Now, on the schematic is marked that it should be 5 microfarad. Now, 5 microfarad does not exist anymore, or if it does, you probably would have to pay quite a bit of money to get a specific 5 microfarad 16 volts capacitor. But what I did have was a 4.7 microfarad. So I replaced this capacitor, since it is an electrolytic, together with all the other electrolytics on the PCB. Or so I thought. I had a closer look at the capacitor because I wanted to check whether the polarity of the capacitor was correct. And indeed, it is correct. So the minus of, or the cathode of the capacitor is indeed connected through a resistor to the base of the vertical oscillator transistor. But lo and behold, when I took a look at the value marked on the capacitor, I didn't read 4.7 microfarad, but I read 47 microfarad. So it seems I made a mistake. When I replaced this capacitor, I inserted a new capacitor of not 4.7 microfarad, but of 47. Now, would that have an influence on the oscillator? Yes, of course. And you could say, as a rule of thumb, the bigger the capacitor, the lower the frequency of the oscillator. And in fact, it's even quite possible that this oscillator circuit would not produce any kind of frequency at all. Yeah, so it would not oscillate at all because of the erroneous value of this capacitor here. So what I'm going to do now is I'm going to unsolder a brand new 47 microfarad, and I'm going to replace it by a brand new tiny 4.7 50 volts 4.7 microfarads 50 volts electrolytic capacitor. Alright, I'm ready to solder the 4.7 microfarad capacitor to the PCB you see here. And I managed to release from the PCB the 47 microfarad I had erroneously mounted to it, and I'll show you the value if I can find it. And there you are. So as you can see, this is a 47 microfarad 50 volts, and I'm replacing it by a 4.7 microfarad capacitor. Okay, I mounted back the CRT drive PCB with the replaced electrolytic. So let's switch on the TV and see whether it made a change. Okay, the output voltage of the vertical output transistor is 9.25 volts, whereas the schematic says it should be 9 and a bit. Let me see. 9.4. Okay, so it's a tiny little bit low, but, well, no, it did not make any difference, which is unfortunate, of course. So let's see if I change the vertical frequency, whether that makes any difference. Well, it does become a bit brighter in one direction and less bright in the other, but that doesn't seem to change much. Okay, let's change the bias a little bit on the vertical output. Oh, that's a bit too much. 9.3, 9.4 I mean. Yes. Okay, so now yeah, the vertical output transistor becomes really hot after a while, which seems to suggest to me that it's being overdriven, yeah, and therefore drawing way too much current, which of course would suggest that it is being driven in continuous mode and not in pulsed mode, which of course would mean that it would get much less hot than it does now. Okay, so well, that's a bit of not getting any kind of vertical deflection, and the voltages around the vertical driver transistor and the vertical output transistor are, let's say, close to normal, and all the voltages around this one were completely off. Well, I thought that probably the trouble would be somewhere around here. Now, I did measure out all the resistances. I changed this capacitor to the correct value, which is 47 microfarad. And I also checked the transformer. So all the parts except the transistor checked out fine. So what I did in the end is the logical next step, which is to replace the vertical oscillator transistor, which is this one here. Now, according to the schematic, this would be a 2SB51 PNP transistor. It's an old one. It's in a T05 housing. So I suppose this is supposed to be a power transistor. Now, I did check on the internet, and it seems that this transistor only can take about 200 milliamps of collector current, which is not that much if you think about it. But okay, I thought, okay, I need a PNP transistor that can draw, let's say, 200 milliamps on its collector, and which can work around, let's say, 12 volts or a bit higher. So I started looking in my stash of transistors, and I found this transistor, or well, I should say these transistors. They are not very well known transistors. I mean, the S9012, really, if you would say a BC558, I mean for a PNP transistor, yes, I think everybody knows that transistor, but an S9012, not so much. Now anyway, the only PNP transistors I had were, let's say, all-purpose ones, like this S9012 or like a BC558. Now, it turns out that the S9012 can take a little bit more current than a BC558 on its collector, and it can also dissipate a little bit more power, so about 600 milliwatts, contrary to the BC558 that can only dissipate about 500 milliwatts. Now the thing is, the BC558 can take a lot more voltage than the S9012. But since this is a low voltage circuit, I thought I would go rather with this one, since it can dissipate a little bit more power. It also has a little bit better temperature characteristics than the original one. So I thought, okay, let's go for this one, and that's exactly what I did. If you look on the circuit board, you'll see that I mounted the transistor. Let me see if I can make it focus. You can see it over here. Okay, let me see. Yeah, there it is. So this is the S9012 PNP transistor. So I replaced the original PNP transistor, the 2SB51, which is this one. I don't know why my camera refuses to focus, but okay. So I replaced this one for that one, because the characteristics are rather similar of both transistors. So let's have a look whether that changed anything. Okay, well, I'm monitoring the voltage on the vertical deflection coil, which for the moment is 0 volts, of course, because the TV is off. And well, I directed the camera at the screen to see how it will react to TV once we switch it on. So well, here we go. Oh yes, there's sound, by the way, but for the moment it's just how do you call it, white noise, obviously, since hey, and look at that. I think we have deflection, my friends. Yep, and the voltage on the deflection coil is 9.38 volts, so almost 9.4, which is great. Well, see, oh yeah, there it is. Oh. Well, it's not perfect though, because the lower third of the screen is still without an image. So let me see, what do I need to set next? Okay, well, according to this, yeah, the 5 potentiometers on the side, let me switch on the light, so, or let me take the camera. So what I need to do now, if you take a look at the schematic, is I need to set the height, the vertical linearity, and the horizontal frequency. Well, that not really, but certainly the vertical linearity and the height. So let's just do that. Okay, let me set up the camera. So I think you have enough light to see what I'm doing. Hang on. Okay. Well now. Okie dokie. So let's see what effect we get when I turn the vertical linearity. Okay, so okay, I compress the image a bit. Not a lot though. Okay, and now let's see what happens if I set the height. Not so good either. Okay, the image is too high. The image is too high and I can't seem to make it lower. Okay, well that's a bit of a bummer, but the output transistor does become hot, really hot, and the voltage to the deflection coil is dropping a little bit. Now it's 9.3 volts instead of 9.4 volts, but okay. Okay, so this isn't perfect by any means, but it's a lot better than what we had before. Well, I mean, obviously before we didn't have any image at all, so by any means this is an improvement. Yes, I would call this an improvement for certain. Okay, so the next thing I need to investigate, now that we got the vertical deflection to work again, is to see why the image, let's say the lower fourth of the screen, is black. So why I can't expand the picture to the bottom of the CRT. So that's what I need to investigate next.